4.5 zeros of the polynomial functions. So in this section, we are going to learn how to find possible rational zeros, how to find the rational zeros, and how to find the real and the non-real zero solutions of the polynomial function. Finding all possible rational zeros of polynomial functions. Real quick here, under this page, on this slide, I have that external resource from YouTube. I personally really like it. So you can click on the link to watch the video if you feel need more help. Rational zero theorem. The polynomial p of x, we have this long notation. Now keep in mind, with a polynomial function, in order to use the all possible rational zeros, in order to use this theorem, we need to keep the coefficient number. Each of the leading coefficient number or each of the coefficient number term are integers. That's an easier way for you to finding all possible rational zeros. Now, with the polynomial, when you have the polynomial function, the highest degree power term, like say 2x power 7, and then you have x6 plus 3x power 4, and just keep going. When you have the function like this, it's hard for you to use the factoring, right? There's no way you can solve for it unless you use the calculator. But the way we want to learn this subject, we want to do it manually to break down the polynomial function into the pieces. So we can solve for x from those pieces. We call depress the equation or depress the function. So how can we depress the function into the deep pieces? We use the finding all possible rational zeros. So if you look at the bottom page here, we go with the first step is finding all possible rational zeros. Now, all possible rational zeros, they are coming from P over Q. So P over Q. P is the all possible factor of your coefficient constant term. Let me write down here, all factors of the constant term, which means the last term of your polynomial function. Divide by all factors of leading coefficient term. Leading coefficient term, which means this guy, a sub n. A sub n, leading coefficient, is a number attached with your highest degree power term. We call leading coefficient. So this is a leading coefficient. The rest of the coefficient, we just give the name the coefficient. And the last term, this is a constant. So the first step, in order to break down your polynomial function, we use these two numbers to finding all possible rational zeros. Then from there, we can break down the function. So how do we do that? We use this example, these two examples here. We do the practice here. Finding all possible rational zeros. So look at the constant term. This is a 1. Okay. So how can we finding all possible rational zero of this polynomial function? So we look at the last term. This is a constant term. And the leading coefficient term, which is 1. So your P over Q is 1. We will have possible factor would be positive, negative 1, right? So you have positive, negative 1. Leading coefficient term, the coefficient number is 1, so we have the positive, negative 1 as well. So all possible rational 0, you will have 1 divided by 1, just 1, right? But it comes with a two sign with it. So you have 2 possible rational 0. So all possible rational zeros, they are 1 and a negative 1. We do this practice. All factor of the 6, we will have, write down P over Q here. We start from 1, right? So 1 is a common factor of 6. 2 is a common factor of 6. 3 is a common factor of 6. And the 6 is a common factor of the 6. Over your Q is the leading coefficient 2. So all possible factor of 2 only have 1 and the 2. So you can just consider the number, the factor of the number, and each of the number, they need to carry the positive negative sign. So now we can organize all possible rational zeros coming from 1 divided by 1, which is 1, but you have 2 sign of the 1, so we put a 1, negative 1. 2 divided by 1, you'll get a positive 2 and a negative 2. 3 divided by 1, you'll get a 3 and a negative 3. 6 divided by 1, you'll get a 6 and a negative 6. Now we do 1 and a 2. So when I have the 1 divided by 2, we will have half, right? So you have positive half and a negative half. 2 divided by 2 is 1. So 1 was there. Then you don't represent it twice. 3 divided by 2, you will get 3 over 2 and a negative 3 over 2. 6 divided by 2 is 3. 3 was there. So we stop here. So all the possible rational 0 has all the number listed here. Now look at this function f of x. It's a polynomial because we have 5 terms here. So this is polynomial. Because the coefficient number of each term, they are the fraction. So when you have the function like this is a function, but in order to find all possible rational zeros, we need to make the coefficient number is an integer, because that's an easier way you can find a possible rational 0. So how do we do this one? We can multiply the least common multiple, which is 6. So you multiply by 6 into each term. I multiply 6 here, 6 here. Do that for each of the single term. And then you'll get a 3x power 4, because here reduce, you get a 3. Plus 4x power 3 plus 18x squared minus 9x plus 18. Once you change your function into the integer coefficient term, then you can finding all possible rational zeros from here.